take a look around. Buildings are everywhere, and those buildings account for nearly 40% of all energy consumption and greenhouse gas emissions here in the U.S. A group of Iowa State researchers, led by Iowa State architecture professor Ulrika Pasa, are part of a 5-year, $20 million project among Iowa's 3 public universities that's funded by the National Science Foundation and the Iowa Power Fund to develop Iowa's role in researching energy efficiency and renewable energy.
We're looking at the relationship of building design and energy consumption.
By studying whether buildings perform as expected and which energy strategies work well in Iowa's climate, using several different existing buildings as test sites.
We are studying the Interlock House, which has been built by the 2009 Iowa State Solar Decathlon team.
The Interlock House, which is now owned by the Iowa DNR and used as office space and an activity center, is part of the Honey Creek Resort at Lake Rathbun in southern Iowa.
We've equipped the house with a whole array of sensors which are measuring the various consumption parts of the building and the comfort level of the building, illumination, but also electricity consumption, electricity production. The house is laid out that in the summer it produces excess electricity, which then in the winter gets pulled back from the grid.
Another one of their testing sites is just outside of Boone on the Iowa State Research Farm.
We are now building a test scenario out there with here architecture students and an intern to understand the efficiency of this equipment. To study what we call Desiccant dehumidification system. It was designed by Iowa State mechanical engineering students.
The point of this research is, given the area of the Midwest, it's a very hot, humid climate and cold winters, but this system is trying to take advantage of that condition by the incoming air supply from our house. We are removing the humidity, which is lessening the load it takes to cool that air. And the idea is to potentially save the homeowner, 80% on their cooling load costs.
A big deal that can make a big difference.
Anybody can do it, yes. Making maybe more use of what they actually have. And it also has an environmental impact. It reduces resource consumption, it reduces CO2 emission, it actually reduces the environmental footprint of your own living. I think that is a pretty neat thing.
And it may not be as difficult as you think.
It's actually pretty easy to use less if you know a little bit of what the physics are about in buildings. You don't have to sacrifice any of your comfort understanding. I think sometimes you might have to be a bit more alert with what your environment is like, how, what the weather's going to be like tomorrow.
And that will help you decide things like whether to keep the windows and blinds open during the warmest part of the day.
We are all humans, and it's not the buildings who use the energy, but it's the people who do that. I think this is really important. I think, everybody knows buildings, right? Everybody uses buildings, yet it's often not really well understood how much buildings actually can alter or can vary and how much that actually affects the energy consumption.
And it's a hot topic.
I think it's becoming more and more an issue and the question because people are concerned with their budgets, and energy is a big part of everybody's expenses each month.
Another reason why this research is so important.
Reducing that consumption by the design of the building, or what we are also looking at by the future retrofit of the building, has an impact on the whole life budget of a building.
This research has sparked the interest of high school science teachers across the state.
There will be 4 schools which will be equipped so that it also can act as a teaching tool, so that kids in their science classes learn science through building energy consumption. It's very hands-on. You can give somebody a sensor in the hand, and then they can take data from their building over a course of a certain time, and then they can plot different humidity levels, different temperatures, and can understand that relationship of air and humidity.
Showing how small changes here and there could save a lot of money and help our environment down the road.